Hello and welcome to Grade Up. How are you all? Good evening, everyone. How is your preparation going on? Yes. How's your preparation going on, dear friends? Good. Yes, so today we are here for RRB JE rapid revision of important questions on electronic components and materials. Okay, so should we begin the session? Yes, come on, join the session. Are we ready? Yes. Everyone ready? Yes, come on. Let's begin with the first question. The process of adding impurity in a pure semiconductor. Pure semiconductor is also called as intrinsic type of semiconductor. Okay, intrinsic type of semiconductor. When you add an impurity, then it becomes doping. Yes, intrinsic type of semiconductors are doped. Intrinsic type of semiconductors are added with an impurity, and this process is known as doping. Doping is done to enhance the electrical property of a material. Doping is done to enhance the electrical property of material. Okay. Next, at room temperature, a semiconductor material is, yes, at room temperature there is no thermally generated charge carriers, so it will be behaving as a perfect insulator. Okay, at room temperature the charge carriers generated will be 0. Ni square equals to A naught T cube. Do you remember this? E raised to the power minus Eg naught by Kt. So, no, actually you have to go by this formula, that if the temperature is increased, charge breaking will be there, means covalent bond breaking will be there, and electrons and deficiency of electrons is called holes will be generated. So if the temperature is increased, more number of electrons and holes are generated, but at zero temperature there will be no thermally generated electrons and holes, and you will get perfect insulator. Okay, if it is of room temperature, at room temperature it will be slightly At room temperature, semiconductor material is conducting. It is conducting. As the temperature is increased, electron and hole pairs will be generating. At perfect zero, it is perfect insulator. Temperature increases, then conductivity increases. So it becomes conducting. Okay. When are your RRB JE exams? Tomorrow? Do you have RRB JE exams tomorrow? Tell me. 31st and 1st is the date for electronics. Okay, good. Then you have ample of time. Okay, come on, let's move to the next question. The temperature coefficient of intrinsic semiconductor is. What is the temperature coefficient of intrinsic semiconductor? If the temperature increases, it should be temperature coefficient of resistance. Okay, as temperature increases, sigma conductivity increases and resistivity decreases. So it is negative temperature coefficient. As temperature increases, resistivity decreases, it is negative. Correct. The most commonly used semiconductor material is. The most commonly used semiconductor material, tell me. Silicon. Silicon is the most commonly used semiconductor material. Correct. Because it is easier to fabricate silicon, and oxidation of silicon is SiO2, and in the fabrication process of circuits, or you can say VLSI circuits, it is easily fabricated. Okay. And what is the range of it? Its range is up to 175 degrees Celsius. It works perfect. Reverse saturation current is also minimum. Correct option. Okay. Next, to obtain P type of semiconductor, a pentavalent impurity is added, a trivalent impurity is added, both are added, none of the above. Yes. What will be the option? To convert an intrinsic semiconductor to P type, trivalent impurity is added so that there is deficiency of electrons and hole is formed. Okay. So major conductivity is due to holes. So a trivalent impurity is added. Correct. Which of the following will serve as a donor impurity in silicon? Which of the following will serve as a donor impurity in silicon? Tell me. Yes. Indium, antimony. Correct option. Antimony is the correct option. Yes. Correct option. Antimony. Boron, indium. These are of P type. Germanium is intrinsic. Okay. Phosphorus, antimony. These are N type. Okay. Donor type impurities. Next, when donor type of impurity is added to a semiconductor material, a donor type of impurity is added to a semiconductor material. Okay. Then electrons are generated and the material is P type. Electrons are generated and the material is N type. Holes are generated and the material is P type. What will be the correct option? When a donor type of impurity is added to a semiconductor, electrons are generated and the material is N type. Electrons are generated and the material is N type of semiconductor. Okay. At absolute zero temperature, an intrinsic semiconductor behaves like an insulator. It is absolute zero temperature in this case. So intrinsic semiconductor material will behave like, yes, low electron energy, low drift velocity, non-availability of free electrons and non-recombination. It will be non-availability of free electrons. There should be charge carriers to support conductivity. There should be charge carriers to support conductivity. If the charge carriers are zero, it means conductivity will be zero. Next, very good response. Keep it up. A N-type semiconductor has dash conductivity at 0 degree K. N-type semiconductor has zero conductivity. Yes, zero, high, small, none. It has zero conductivity. Yes, at absolute zero temperature, its conductivity is zero. Okay. The electron in the last orbit of an atom is called. What is the electron in the last orbit called as? What is the electron in the last orbit called as? Valence electrons. Correct. These are called as valence electrons. Okay. Thermally generated electrons are the electrons that have broken the covalent bond and came out of that energy state to conduct. Okay. Correct option. The materials suitable for the permanent magnets are. Yes. Which materials are suitable for the permanent magnets? Tell me. Which materials are suitable for the permanent magnets? Hard magnetic materials. The material is a hard magnetic material or it is a soft magnetic material, depends upon the width of the BH curve. It is having wider width. It is having wider width. And if the material is a soft magnetic material, then it is having narrow width. Okay, of the BH curve. It is BH curve. It is your BH curve. Okay. So for permanent magnets, you will refer to hard magnetic material. This point is known as retentivity, and this point is known as coercivity. So for hard magnetic materials, coercivity should be high. It means amount of magnetic field to demagnetize it should be very high. Okay. Which of the following cables can transmit data at very high speed? Yes, which of the following can transmit data at very high speed? Flat cables, coaxial cables, optical fiber, twisted pair. Optical fiber, it is having bandwidth of 600 megahertz, maximum operation frequency that it is having maximum operation frequency 200 kilohertz. It is having maximum operation frequency of gigahertz, 10 gigahertz. Okay. Lead storage battery is reversible cell functioning as electrochemical cell during discharging, and electrolytic cell during recharging. Electrochemical cells are those cells which provide you energy when chemical process is creating the electrical energy. Okay. When chemical process is creating the electrical energy. So it is electrochemical when discharging, and during recharging it is electrolytic. For measuring voltage drop of connector, voltmeter is connected across each side of the connector in parallel. If you have to measure connector loss, you have to place voltage here. voltmeter को यहाँ place करना पड़ेगा connector loss के लिए. How will you measure the voltage drop across connector? You need to apply voltmeter across the connector. Yes. Magnetic materials may be readily magnetized in either directions. The materials which can be magnetized rapidly or readily in the either directions are, yes, they are soft magnetic materials, hard magnetic materials, high eddy current loss materials, and high hysteresis loss materials. So for easy magnetization and demagnetization, we prefer soft magnetic materials because BH curve is thin and no much energy is lost. Okay, energy dissipated in magnetizing and demagnetizing is less. Did you get this thing? Yes, it is thin and tall. It is having high saturation magnetization as well as high permeability. High permeability. Okay. Selva Kumar, from where did you get answer that? Wrong answer. In optical fiber, deflection of light occurs in. Where is light deflected? In optical fiber, where is light deflected? Light is deflected in core or cladding? Tell me, where is the light deflected? It is deflected in core. Correct option. It is deflected in core. Okay. Battery used for the aircraft is, yes, which battery is used for aircraft? Which battery is used for aircraft? Nickel iron battery? Nickel iron battery? Correct option. Nickel iron battery is used for the aircraft purpose. Okay. Nickel iron battery is used for aircrafts. Lead acid battery is used for household. Okay. Dry cell batteries are used at different places in gadgets. Okay. BNC connectors are alternative to RCA connectors. Okay. So have you seen BNC connectors? BNC connectors are used to connect CRO. CRO पे signal देने के लिए BNC connectors are used. BNC cable is used. Okay. So these are used at all of the above. These are used in armature radio antennas. These are used in recording studios, and this is used in aviation electronics also. All of the above. Okay. Soft magnetic materials. What should be the property of soft magnetic materials? What should be the property of soft magnetic material, dear friends? Yes. I already told you in the example that these soft magnetic materials have narrow BH curve. The BH curve is narrow. It means less energy is dissipated to magnetize as well as to demagnetize it. Low saturation magnetization, wrong answer. It should have high saturation magnetization. The BH curve is narrow, okay, and tall. So it is having high saturation magnetization, large permeability, low corrosivity, high retentivity. These are the properties of soft magnetic materials. Okay, these are the properties of soft magnetic materials. In a optical fiber cable, which phenomena occurs for signal to propagate? Yes, which is the phenomena for signal to propagate? Modulation, reflection, refraction, all of the above. Yes, it is reflection. It is reflection. Total internal reflection is required. Okay, inside core there is cladding. Here you have cladding. Here you have cladding. In core there is total internal reflection. For total internal reflection to follow, the angle should be greater than the critical angle. The angle should be greater than the critical angle. Okay, and what is this critical angle value? It is sine inverse n2 by n1. Sine inverse n2 by n1, where n2 is the refractive index of cladding, n1 is the refractive index of core. Okay, the angle of incidence should be greater than the critical angle for total internal reflection. Okay, is it fine? In a dry cell, which of the following are used as electrolytes? Which of the following are used as electrolytes in dry cell? Have you seen a dry cell? A dry cell is just like this, used in your torches earlier. A graphite or carbon rod with a brass capping. It has a brass capping and zinc container. Ammonium chloride paste is filled here. Ammonium chloride paste is available here. So electrolyte is ammonium chloride and zinc chloride. Okay, ammonium chloride, NH4 seal, ammonium chloride and zinc chloride. Okay, RJ11 is the name given to registered jack 11. Registered jack 11. Okay, it has, what will be the answer? 4 wires. Correct. RJ has 4 wires, 2 pairs. Correct. My answer is A. Why should you give A as answer? RJ11 has 2 pair 4 wires. Okay. RJ45 has 8 wires and 4 pairs. Okay, 8 wires and 4 pairs. Which of the following material is considered as a non-magnetic material? Yes. What is the use of RJ11? RJ11 is used in your telephone. RJ11 is used in telephone. RJ45 is used in Ethernet cables or LAN cables. Which of the following material is considered as a non-magnetic material? Tell me. Which is the non-magnetic material here? Non-magnetic material here is diamagnetic material. Okay, this diamagnetic material. Why it is called as non-magnetic material? Because this diamagnetic material will not have any dipole of its own. Magnetic dipoles are absent in the diamagnetic materials. Magnetic dipoles are absent in the diamagnetic materials. Okay, in ferromagnetic material, that the orientation of the dipoles are like this. All the dipoles, magnetic dipoles, are aligned in a particular direction. Okay? And anti-ferromagnetic materials, it is anti-ferromagnetic. Okay? Equal and opposite dipoles. Equal and opposite dipoles. It is ferromagnetic, it is anti-ferromagnetic, and anti-ferromagnetic does not exist. Anti-ferromagnetic does not exist. It is ferromagnetic, equal, unequal, anti-ferromagnetic, it is ferromagnetic. Ferromagnetic is actually unequal and opposite orientation of dipoles. Unequal and opposite direction of dipoles. So in the examination, this dipole arrangement can be asked and you are supposed to find out the type of material. So is it clear to you now? In the examination, question can be given in the form of magnetic dipoles. You are supposed to find out the dipole, find out the type of the material. So can you now find out the type of material from seeing the dipole? Yes. Dipole के orientation से can you find out the material? Tell me. Yes. You can easily calculate or you can easily find out. Okay. What is the fiber optics frequency? What is the fiber optics frequency? इधर बताइए, इधर D C okay. Remember this band. Remember this band. R M I V U X G. Radio waves, microwaves, infrared, it is visible, it is ultra, okay, it is X-ray, and it is gamma ray. It is in order of increasing frequency. It is in order of increasing frequency. Now you tell me. Now you tell me. What should be the optical frequency? Yes. What should be the optical frequency? D. Terahertz, gigahertz, I'm expecting a good, means you people are having that ambiguity in the answers. 1450 gigahertz. Acha. More than 1 gigahertz you using waveguide, that is a different case. But in case of fibers, you tell me, which frequency are you going to use? A, B, C, D, C, C, gigahertz to terahertz. I leave it up to you. Yes. C is final. Let us see. Let us see. Hold on. Hold on. Hold on. Have you seen 850 window? There are different windows to transmit 13, 10, 15, 50. Okay. There are different windows to transmit. Okay. So the closest answer will be in the terahertz range, and it will be this. Okay. Batteries used in mobiles are called as, yes, what are the batteries used in mobile phones? Secondary batteries. Secondary batteries, what are secondary batteries? Secondary batteries are those batteries which can be charged as well as which can be charged multiple times. Means electrochemical reactions, it is possible to regenerate the voltage. Okay, so it is secondary batteries. Okay, it is secondary batteries. Okay, like lithium ion batteries. Okay. Okay, these were the important questions from the topic majorly focusing on the batteries. Okay, majorly focusing on the batteries and magnetic materials. These were important topics that you have to focus. Okay, these were the important topics that you have to focus. Okay, so it was all in this session. Okay, yes, there will be sessions, hope so. Is water paramagnetic or diamagnetic? You tell me. You tell me what is water. No, I haven't covered MCB and relays in YouTube. More questions? Okay, let us see more questions. Let us see more questions. Come on. You people are interacting among you only. RJ45 connector is known as. RJ45 connector is also known as. Yes. What is RJ45 connector? RJ name is given to registered jack 45. RJ45 name is given to registered jack 45. I already told you it has 8 wires. It has 8 wires which are in 4 pairs. Okay. It is registered jack 45. Good attempt. The magnetism remaining in the magnetic material. The magnetism remaining in the magnetic material when the magnetic field is reduced to 0. Yes. What is the magnetism called? When the magnetic field is reduced to 0? It is called as residual magnetism or retentivity. Okay, or retentivity. Correct? Yes, correct. Okay. The typical optical fiber has high refractive index core and low refractive index cladding. Low refractive index core and high refractive index cladding. Uniform refractive index core surrounded by, yes, what will be the answer? What will be the answer, dear friends? Core is always having higher refractive index than cladding. It is N1. Refractive index of core is greater than refractive index of cladding. Okay. Core will be having greater refractive index than cladding. Correct option. Correct. Which of the following is an example of secondary battery? Yes. Which of the following is an example of secondary battery? Lead storage battery is a very common example of secondary batteries. Okay, lead storage battery is a very common example of secondary batteries. Correct. Very good. ELCB and MCB. ELCB and MCB are called as circuit breakers. These are circuit breakers. MCB is miniature circuit breaker. MCB is miniature circuit breaker, and it is used for over current protection. Okay, over current protection, overload protection. In overcurrent you can say overload protection as well as short circuit protection. Okay, short circuit protection. Is it? So you have to remember one thing of MCB, that is MCB is miniature circuit breaker. It is given in your syllabus, so at least definition point of view it is very important, and it is used to protect from overload as well as from short circuit. Okay, keep this thing in mind. ELCB is earth leakage circuit breaker. In this actually कॉयल के क्रॉस में करंट को देखते हैं. देयर शुड नॉट बी करंट मोर देन 10 माइक्रो एम्पियर्स करंट डिफरेंस. ओके, which topic is more important, sir? Microcontroller or microprocessor? Microprocessor is most important. A material with unequal anti-parallel atomic magnetic moment is called as, yes, what is that material which has unequal anti-parallel arrangement of magnetic dipoles? Unequal and anti-parallel, two things in mind, so it will be C, ferrimagnets. Correct, ferrimagnets. Okay, antiferromagnetic have equal and opposite orientation of dipoles. Antiferromagnetic has equal and opposite dipole moments. Okay, in order to increase ampere-hour rating of the battery, the cells are connected in order to increase ampere-hour rating of a battery, cells are connected in series. एम्पियर-आवर रेटिंग के लिए cells will be connected in series. अच्छा, cells will be connected in parallel to increase current. If current increases, ampere-hour rating will increase. Current supplied by it is I, current supplied by it is I, current will be 2I. To increase ampere-hour rating, it should be in parallel. To increase voltage rating, it should be in series. Okay. Yes. Which type of device is used in MCB? Which type of device is used in MCB? In MCB, for triggering to occur, the first device is bimetallic strip. There is a bimetallic strip, okay. And second, due to short circuit, there is flux to be generated by coil that triggers the triggering of MCB, okay. That triggers the triggering of MCB. There is a bimetallic strip. Bimetallic strip is consisting of two strips. One strip has, there are two strips in which one strip has low temperature or low thermal coefficient of expansion, and this strip suppose has more thermal coefficient of expansion. When current will flow through it, then heat will be generated, I square RT. There will be unequal expansion due to heat generation, so it will try to bend. It will try to bend. That bending causes circuit to trigger, and circuit will be cut off due to overcurrent, overload. Okay, overload. Is it clear? 34A option. Bedding that is used in the underground copper cables. The bedding which is used in the underground copper cables, it is made up of, yes, have you seen an underground cable? An underground cable has core. Over the core insulation is done. Okay, over the core insulation is done. This insulation is of PVC. This insulation is made up of PVC. Okay, so over this there are different cores like that, and over this there is a metallic sheath. Over this there is a metallic sheath. This metallic sheath is made up of lead. To protect, this metallic sheath is made up of lead to protect the cable from moisture. Okay, over this there is a bedding done. Over this bedding is done. Why bedding is done? Because over the bedding there is steel tape. So to protect the cable and to provide a cushioning for the steel tape, PVC bedding is used. PVC bedding is used. Mesh is present on the PVC. Mesh is present on the PVC. Okay. What is sheath? Sheath is actually covering. Sheath is actually covering, solid covering. Okay. Metallic sheath. This metallic sheath is made up of lead. This metallic sheath is made up of lead to prevent moisture. To prevent moisture to go into cable. Jute or Hessian tube, jute or Hessian tape is also used. Yes, correct. You can use jute or Hessian tape. Yes. Okay. So bedding in the copper cable is made up of PVC. Bedding should be such a material that can absorb the shock due to upper armoring. Okay. In MCB which cuts off the electric supply, an MCB which cuts off the electric supply in case of short circuiting or over voltage. Tell me. It is due to the heating effect of current as well as due to the magnetic effect of current. Both the options B and C are correct. It is due to the heating effect. Heating effect in case of bimetallic strip. Okay, heating effect in case of bimetallic strip, and magnetic effect of current in which coil pushes the plunger to itself to cause triggering. Both B and C are the correct options. Both B and C are the correct options. Okay. A sheath is used in the cable. Why is the sheath used in the cable? Sheath is made up of metallic sheath. My dear friends, these cables are actually, they may be underground in sea or water. Okay, so to protect the core which is inside the metallic sheath, okay, this is core. To protect the core, there is a PVC insulation, and over this insulation there is a metallic sheath. This metallic sheath is made up of lead. This metallic sheath is made up of lead. So it is to prevent the moisture from entering the cable. Okay. Its primary purpose is to protect the moisture from entering the cable. Okay. If a battery, the positive terminal of the battery is connected to the negative terminal of the other cell. Okay. There is a battery in which positive terminal of one cell is connected to the negative terminal of the other cell. Then which kind of arrangement is this? Is this a serial arrangement? Serial arrangement is positive of one is connected to the negative of other. It is serial arrangement. It is serial arrangement. Correct. Circuit breaker device can be used in place of fuse. The circuit breaker device which can be used in place of fuse in the domestic electric wiring is MCB. Over current को protect करता है. Fuse was having an application to protect short circuit, but MCB has an advantage. It protects the overload condition also. It protects the devices from the overload conditions also. Okay. For low voltage applications below 1, the cables used are, yes, the cables used are single core cables generally. The cables used below 1 kilovolts are called as single core cables are there. Okay, single core cables are there. My dear friends, oil filled cables are those cables which are having very high voltage to protect dielectric breakdown. Oil filled cables are there. Oil cooling is provided. Okay. The storage battery generally used in electric power station. Yes. In electric power station, which type of cable is used? Lead acid batteries are generally used. Lead acid batteries are generally used. There is a new type of battery. There is a new type of battery which is often used in today's day. It is VRLA, Varla batteries. Varla batteries. These Varla batteries are valve regulated lead acid batteries. Valve regulated lead acid battery. These Varla batteries are also acting as a dry cell. Varla batteries are valve regulated lead acid batteries. These Varla batteries are dry type of cells. Okay. These are dry batteries. Okay. The device which is used for switching in a switched mode power supply. SMPS. SMPS full form is switched mode power supply. And the device which is used in SMPS is MOSFET. And the device which is used in SMPS is MOSFET. MOSFET use करते हैं. MOSFETs are used. MOSFETs are used because the switching losses are least in MOSFET. Switching losses are least in MOSFET. Okay. Varla batteries are used in storage in telecom sector much. It is used in telecom sector much. Okay. What about conduction losses? Conduction losses, see, in power supply, conduction losses are depending upon F VDD square. Okay. So this frequency is less, so conduction loss will be less. Okay. Actually, conduction losses in MOSFETs are also very less. Drain resistance RDS is very less. Drain to source resistance is very less. Switching time power will be dissipated, that is proportional to this. And the added advantage is it can be fabricated on a VLSI chip. it can be fabricated on a VLSI chip. Okay. So it was all about the session, important topics which we are to complete. Okay. So this revision course is scheduled per day at the 6 p.m. I hope that before your examinations we can provide you best quality contents so that you are on a proper track and follow this. Okay. Relay is a electromechanical switch. Relay is a electromechanical switch. Okay. Tomorrow there will be a session. Yes. So it was all, my dear friends. Okay. How was this session? Did you enjoy this session? Yes. Did you enjoy this session? This is a time for you to revise your stuff. Okay. To revise your stuff means revise and revise more things. Okay. Circuit breaker will be acting first. Okay. Okay. We will provide more number of questions in the upcoming sessions. Don't worry. Okay. We will plan out accordingly. So thank you all for DCN का भी revision कल हो जाएगा. Tomorrow we will do DCN. Okay. Don't worry. Tomorrow we will do DCN, data communication and networking. Okay. Tomorrow DCN. Okay. Most important topics helpful for the examination. Prepare more questions with more shifts. Okay. Our number system is important. Number systems are more important. Number systems are most important in digital circuits. Okay. Don't miss them. Okay. Thank you all for joining this session. We will have more discussion of the questions in the upcoming sessions. Thank you for joining Grade Up and all the best for your preparations. Thank you.